Hi, welcome to Chem with Chem. In today's session, we're going to be working question 6 of Chemistry Paper 2 from the June 2019 sitting. If this is your first time to the channel, welcome. Be sure to check out all the materials that are here. Leave a like if you find value, share with your friends, and consider subscribing and turn on post notification so you'll be notified the moment new material is added. Now, let's dive in. Metal alloys are often used in place of metals because of their enhanced properties. Part 1. Define the term alloy. All right. So this is 1 mark. So an alloy is a substance that is formed when a metal is mixed with other metals and or non-metals. So it means that this metal can be mixed with a metal, this metal can be mixed with a non-metal. All right. So the common mistake we tend to make is to just think that an alloy has to be metals mixed together. All right. So let's get that in for our 1 mark. Part 2, name 1 alloy of aluminum and state its use based on one of its enhanced property. So there are 2 alloys of aluminum that we know, and we would have looked at this in a previous session. So we have duralumin. I think I worked on the pronunciation since the last time, and we have magnesium. So we're just going to work with 1. So we're going to work with magnesium. It doesn't have as many enhanced properties as duralumin. So the enhanced property of magnesium is that it is resistant to, it's resistant, it's a T. It's resistant to check. So magnesium is resistant to corrosion, and as a result of that, now we can use this to make window frames, door frames, and roofing materials. It can be used to make window frames, door frames, roofing materials. Now, the other alloy, duralumin, it has more enhanced properties, a lot more enhanced properties, and therefore more uses. But I think in our previous session, we looked at duralumin. We just want to ensure that we learn other ways. So that one has, duralumin has low density. It's a very good conductor of heat and electricity, high melting point, good malleability and ductility. It's very strong and hard. So duralumin is probably the better one to revise or to practice or to study, because you have all of about 6 or so enhanced properties. So the likelihood of you, if you forget 2 or 3, you still have 3 others. And then we have to be able to link the properties with the uses. So low density makes duralumin very good for aircrafts and car bodies. They're light, very good conductor of electricity, heat and electricity, makes it being able to be used as electrical cables and so on. It has good malleability, good ductility, so we can draw it into wires, hammer it into cans, bottle caps, and so on. So the possibilities are endless, but we just want to mix up the thing somewhat. All right, so just like that, we have 4 marks. Part B. A student conducted an experiment to investigate the reactivity of each of the following metals: copper, iron, zinc, and lead by using solutions of their sulfate salts. The data presented in Table 3 shows whether a visible chemical reaction took place when each metal was added to the 4 sulfate solutions. And the key is there. Where there's a tick, it means that a visible chemical reaction took place. If there's an X, it means no visible chemical reaction took place. Doesn't mean that one wasn't taking place, but we use invisible or no visible chemical reaction to actually determine if one took place. Now, this might be hard for you to visualize, but you can check out the card above for a reaction or an experiment like this one. Similar. The only difference is that we did not tell you what the metal solutions were, or what the metals were. We call them metals A, B, C, and D. And then we had like the nitrate or the sulfate of the different metals. So this one is making it a little easier. They give you the metals. So with knowledge of the reactivity series, you can go ahead and just know what is supposed to happen. So you can check that out. The card is above. How I look at this or how I approach this, you can think of it as football. So we have the metals on our right and the metal solutions are on our left. So we will take iron, for example, and we add iron to a solution of copper sulfate. And if there's a visible reaction, which there is, the tick is there, it means that iron would be taking the place of copper. A displacement reaction will be taking place. All right. In our video, in our experiment, we call it the reducing ability of metals experiments. You can check that out. It should be helpful. It gives you color changes. You're able to actually see the visible chemical reactions as they occur. So from this one, the more ticks we see, then it means that a visible reaction is actually taking place. So let's see if we can interpret this. So when iron was added to copper sulfate, there was a tick to say there was a visible chemical reaction. When zinc was added to copper sulfate, a tick means a visible reaction took place. When lead was added to copper sulfate, it means that a visible reaction also took place. So everybody, all 3 metals here actually reacted with the copper sulfate or took the place of the copper sulfate. That's one way to look at it. We could also look at it going down instead of going across. So we could look to see how iron fared against all the other 3, because we're not going to put iron with iron sulfate, even though when they did, there was no visible chemical reaction. So maybe it's best if we try to interpret the data going down. So we look at how well iron did. So if we're looking at iron, we look at if iron was able to displace or take the place of copper. Yes, it was. Was it able to take the place of, well, we wouldn't put it with iron. There's an X there for all of them. When iron goes with iron sulfate, zinc goes with zinc sulfate, lead goes with lead sulfate. So that doesn't really count. So it was able to take, there was a visible reaction with copper sulfate, iron and copper sulfate. There was also a visible reaction with iron and lead sulfate. So iron would have won for 2. All right. For zinc, there were 3. Zinc was able to, there was a visible reaction with copper sulfate, there was a visible reaction with iron sulfate, and there was a visible reaction with lead sulfate. And then for lead, there was only 1 visible reaction. Lead was able to displace copper from the solution of copper sulfate, but it was not able to displace iron or zinc. So we're now going to use this information to answer the questions that follow. So from this, based on the number of ticks, we can determine, before we even get into the questions, we can determine who the winner was. And it's like football. So the ones that give you, the one with the most ticks, that is the one that would be the champion. So the one that's in first place would be ZN, just as a guide. It has 3 ticks. It would have reacted with 3 of those solutions or displaced those metal ions from their solution. So zinc could be more reactive than the next one is iron. Fe had 2. So 3 wins for zinc, 2 wins for iron, and only 1 win for lead. And oh my, we did not look at copper, but copper had no win at all. Copper did not displace any of the other the metal ions from their solution, from the other 3. So please note that the trend that, you know, I guess as a control mechanism, we added, the copper would have been added to copper sulfate, the iron added to iron sulfate, zinc added to zinc sulfate, lead added to lead sulfate, but copper did not get any tick at all. So it would stand at the bottom of the table. All right, no wins. So 3 wins for zinc, 2 wins for iron, 1 win for lead, and no wins for copper. So let us now bear that in mind and see what we're being asked a little further down. So just by jotting down our guidelines, so from the table above, we had said that Zn was the winner. Zn won 3 matches. Zn won 3 matches. Iron won 2. Lead won 1. And copper won 0. So we can use that now. All that we've deduced, we can now use that to apply to our question. State which of the 2 metals is more reactive, iron or zinc. Give a reason for your answer. All right, so from what we saw earlier, iron or zinc, we know that zinc is more reactive. And we could just look back at what happened when zinc played the match against iron. So zinc was able, there was a visible reaction when zinc reacted with, and I want to get that back. When zinc reacted with iron sulfate, there was a visible reaction. On the other hand, when iron reacted with zinc sulfate, the iron did not displace zinc. So we want to just make a note of that. So we'll say zinc is more reactive let's be more specific. Zinc is more reactive than so zinc is more reactive than iron because zinc displaces, or let's not say zinc displaces, let's say zinc, or because, so zinc is more reactive than Fe based on what we would have observed from the table. Zinc is more reactive than Fe because there was a visible reaction between zinc and iron sulfate, but not the other way around. I want to use evidence that was in the question. Using the data in table 3 on page 22, deduce the order of reactivity of the 4 metals, copper, iron, zinc, and lead, from the most reactive to the least reactive metal. And I think we did that earlier. We said it's zinc. Zinc won 3 matches, iron won 2, lead won 1, and copper did not win any. So zinc is more reactive than iron, which is more reactive than lead, which is more reactive than copper. Part 3. The student recorded the following observations from the reaction between the iron and copper sulfate solution. Observations: reddish brown solid coating formed on the iron strip. Blue color of the solution changed to dirty green. All right. account for the observation made from the reaction between the iron and copper sulfate solution. So let's, first things first. So the reddish brown solid coating that would be on the iron strip would be, so the reddish brown solid is copper metal, which are copper metal arising from Cu2 plus ions being reduced as iron displaced copper. Iron 2 plus in solution is dirty green. So iron, we want to say, we're saying here, so iron took the place of Cu2 plus in the compound. And I want us to write the ionic equation, including state symbols for the reaction between the iron and copper sulfate solution. Now, what the ionic equation is what is showing we normally call it the net ionic equation. It's what is showing what is really taking place at the atomic level. So straight up, this is what is really happening. It's just a transfer of electron process. So we would have started out with Fe, which is a solid. There is Cu2 plus aqueous. Or we could also add to the question up top, or answer up top just now, that copper 2 plus ion is blue in solution. So as it is removed or as it is reduced, the blue would disappear. But we don't want to over answer. So this is pretty much what is happening as we had started just now. So it's just a transfer of electron process. So the iron would pretty much be taking the place of the copper. So we would end up with Fe2 plus, which is aqueous, plus Cu which is a solid. All right, so that's our final answer. Now, where is this coming from? We always show where this is coming from, or we arrive at this. So first it would be Fe solid plus CuSO4 aqueous to give us FeSO4, that's our iron sulfate, plus Cu solid. In the next step, we would break down whatever can be broken down into ions. So this is balanced as is. Fe would write it back, Fe solid. Copper sulfate solution can be broken down into Cu2 plus aqueous and SO4 2 minus aqueous. Iron sulfate, iron 2 sulfate can be broken down into Fe2 plus aqueous and SO4 2 minus aqueous. And copper we would get back as copper, which is a solid. So we would now go through and cross out anything that does not change in moving from the left to the right. We call those spectator ions. So we would cut out or we eliminate sulfate, they haven't changed. And then we check to ensure that everything else is, the charges are equal on the left side and on the right hand side. So we had mentioned in a previous session that we call this the Bible technique, because we balance the equation first, balance the chemical equation, we ionize, and after we ionize, we still balance, and then we leave out. That's where we eliminate anything that doesn't change in moving from the left to the right. And then we check to ensure that our charges are equal on both sides. So on the left side, the charge is 2 plus, on the right side, the charge is 2 plus. So this is what we write back, or we had at the beginning for our answer, but just demonstrating how we actually came to this point. All right, so that's the Bible technique for writing ionic equation. Over time, it becomes second nature. Part C. Some metal compounds are health and environmental hazards. Part 1. Identify which of the metals used in the experiment in B is most hazardous to the environment. So no doubt about it. Copper, zinc, lead, iron. The most hazardous one there, it goes without saying, is lead, PB, or we could just write lead, spell it out, lead. And they want us to state 2 harmful effects of continuous exposure to the metal identified in C1 on human beings. All right, so ever since primary school, we've been hearing about the danger of lead pencil, the danger of lead being in paints, lead paints. And you know, we learned that many toy cars were recalled due to some harmful effects that the lead paint would have had on some toddlers or infants, some little children who actually scraped off the paint and ate it. So lead, we don't really want to come in contact with lead in the environment. Right, so we don't really want to be in contact with lead in the environment. So some of the harmful effects on human beings when we become exposed to them is mental confusion. That's one. It results in loss of cognitive ability. It can result in visual disturbance. When you move on to the medicine at university, you learn a little bit more about how these things actually happen. All right, it can even cause paralysis. So we'll leave it there. And they asked for 2, we gave 4. All right, so just like that, 15 marks, just like that. So please check out the other materials on the channel. There are several more sessions like these. There are experiments to back up some of the theory that is covered here. Please go through. If you find value, give it a thumbs up, share with your friends. If you haven't subscribed, subscribe. Consider subscribing and turning on post notifications so you will not miss anytime new material is added. So this was another session with Chem with Chem. Couple later.